Question 9. f of x is equal to 50x squared plus 38x plus 9 divided by 5x plus 2 squared 1 minus 2x, where x is not equal to minus 2/5 or a half. Given that f of x can be expressed in the form a over 5x plus 2 plus b over 5x plus 2 squared plus c over 1 minus 2x, where a, b and c are constants, part A, find the value of b and the value of c, and then part II, show that a is equal to 0. Well, this is a partial fractions question here, and actually they've been quite nice in giving you the initial format of your partial fraction. So, we're given that it can be expressed in this form. Typically when we want to find a, b and c, the first step would be to multiply through by this denominator on the left hand side here. So the left hand side will just become its numerator, 50x squared plus 30x plus 9. On the right hand side, 1 5x plus 2 will cancel with this 5x plus 2 for a. So you'll have a lots of 5x plus 2, 1 minus 2x. The 5x plus 2 squared will cancel completely with b, so we'll be left with b lots of 1 minus 2x. And lastly, the 1 minus 2x will cancel for c, and leave me with c lots of 5x plus 2 all squared. There can be a temptation to expand brackets and compare coefficients, but actually in this case, the simplest way to find our values of a, b and c would be to make some substitutions for x. And our goal is to make at least some of these terms disappear by choosing appropriate values. So let's let x equal a half. When x is equal to a half, the a term here will disappear as 1 minus 2 times a half is 0, and the b term will disappear, again, as b times 0 is 0. And so on the left hand side, substituting in a half, you'll have 50 lots of a half squared plus 38 times a half plus 9 is equal to c lots of 5 times a half plus 2 all squared. This gives us 81 over 2 is equal to 81 over 4. Therefore, c is equal to 2. Similarly, if we substitute in minus 2/5, this bracket becomes 0 and this bracket becomes 0, which will leave us only the b term. So on the left hand side, substituting in the minus 2/5, we have the following is equal to b lots of 1 minus 2 lots of minus 2/5. This gives us 9/5 is equal to 9/5 b, therefore of course b is 1. So we've done part I, we've found the values of b and c. If we want to show that a is equal to 0, another common substitution with partial fractions is to let x equal 0. So letting x equal 0, on the left hand side we simply have 9. On the right hand side, the 5x and the 2x disappear here, so we're simply left with 2 times 1 times a, so 2a plus b plus 2 squared times c. So 9 is equal to 2a plus b plus 4c. We know b and c to be 1 and 2. This gives us 9 is equal to 2a plus 1 plus 8. Well, that's 9. That's 9. Therefore a must be equal to 0. Part B, use binomial expansions to show that in ascending powers of x, f of x is equal to p plus qx plus rx squared plus and so on, where p, q and r are simplified fractions to be found. And then part II, find the range of values for which this expansion is valid. So let's start with our expansion. And when we have a binomial expansion, in our formula booklet, we have the binomial expansion given to us for the form 1 plus x to the power n, which is the following, where the modulus of x is less than 1. Now, using our answer to part A, we can say that f of x is equal to 1 over 5x plus 2 squared plus 2 over 1 minus 2x. This can be rewritten as 5x plus 2 to the power minus 2 plus 2 lots of 1 minus 2x to the power minus 1. Now here we already have 1 plus x, but we don't yet have that here. I'm actually going to rewrite it first of all. 5x plus 2 is the same as 2 plus 5x. And so now I can take out a factor of 2. And when taking out a factor of 2, this 2 is also risen to the power of minus 2. When you take out a factor, it is also risen to the same power. So 2 to the power minus 2, lots of 1 plus 5 over 2x to the power of minus 2. 2 to the power minus 2 is 1 over 2 squared, which is a quarter. So we have a quarter lots of 1 plus 5 over 2x to the minus 2 plus 2 lots of 1 minus 2x to the minus 1. So I have two binomial expansions here, which I need to complete. And within these binomial expansions, I want to find 3 terms. 1, 2, 3. So I want to go up to the x squared term. Starting then with my 1 plus 5 over 2x to the minus 2. My x is this 5 over 2x, and my n is minus 2. Substituting those into my binomial expansion gives me 1 minus 2 times 5 over 2x plus minus 2 times minus 3 over 2, 5 over 2x squared. Using a calculator or otherwise, that simplifies to 1 minus 5x plus 75 over 4. My second binomial expansion is my 1 minus 2x to the minus 1. Here, my x is minus 2x and my n is minus 1. Substituting those values into my binomial expansion and simplifying gives me 1 plus 2x plus 4x squared. Now bringing these into my f of x expression, where I have a quarter lots of the 1 plus 5 over 2, so that's a quarter of my 1 minus 5x plus 75 over 4x squared, plus 2 lots of my 1 minus 2x to the minus 1 expansion, which is 1 plus 2x plus 4x squared. Expanding each of these brackets gives me the following, and then collecting the like terms, I have 9 over 4 plus 11 over 4x plus 203 over 16x squared. Now, in order for this to be a valid expansion, I need to consider both binomial expansions. So for the 1 minus 2x expansion, my modulus of x value needs to be less than a half, but for the 2 plus 5x, my modulus of x needs to be less than 2/5. Now, since 2/5 is less than a half, my expansion is only valid for modulus of x values less than 2/5.